Next in our unit on conics, we're going to talk about parabolas. So a parabola is the set of all points in a plane that are equally distant from the focus, which is a point, and the directrix, which is a line. So if you look at your resource packet, we are going to look at the parabolas you guys have been looking at, since Math 1 and Math 2. And so here's a normal parabola. It's in terms of x. The y would typically be isolated. We have the vertex. And then here, and you probably haven't really seen this in terms of a parabola before, we have the focus. And then here is the directrix. All right, and so what that definition of a parabola was saying is that if you have a parabola that is perfectly drawn, and I don't think this one is, but if you have a parabola that's perfectly drawn and you pick a point, then you could take this measurement right here and this measurement, and they would be the same. Or you could take this measurement to the focus and this measurement to the directrix, and those two measurements would be the same. That's what the definition of a parabola is saying. And if we have time, I do have a cool little thing that shows that, but I don't know if we'll be able to get to it. All right, so when we deal with conic sections, this is the formula for a parabola that we typically use for conics. And so here we do have the h and the k, and you'll notice that both of them are inside of parentheses, and so we're going to use opposite signs. So hk is where the vertex comes from, and then what we're going to do when we put it in this form is we're going to make sure the y is by itself and that these coefficients are pulled out from the y. All right, so it'll be like a GCF that's pulled out from this. And then we have 4, and the p-value tells you the distance between the vertex and the directrix and the vertex and the focus. Okay, so we know that these are always supposed to be an equal distance. Any point on the parabola should be equally distant from the focus and from the directrix. So the vertex is just like the point that's halfway in between them. All right. We have one more name that we're going to be learning, so that's from the focus. Go ahead and draw a line that goes straight this way, straight across here. And it touches the parabola. So this line right here is called the latus rectum. I have no idea why it's called that. We might be able to look that up. And then these points right here that are on the parabola are called endpoints of the latus rectum. All right, and if these are a distance of p, then this part right here is a distance of 2p, and this right here is a distance of 2p. And so that means that the entire latus rectum is always a length of 4p. Okay, so the length of the latus rectum is 4p. Okay, so typically in this unit, when you graph a parabola, you'll start with the vertex, and then once you'll calculate the focus, you'll go up and you'll plot that point. From there, you'll plot the 2 points that are the endpoints of the latus rectum, and then these 3 points are typically what you'll use to graph your parabola. All right, we also have this alternate form of the equation of a parabola. Remember, this unit we're not really talking about functions at all. We've been talking about equations that are definitely not going to pass the vertical line test. And so for this unit, we are going to have parabolas that are sideways. So here you're going to notice that sometimes you have a y term that is squared, and that parabola could open to the right or open to the left. Okay, so here's how you'll know if it's opening to the right versus opening to the left, or opening up versus opening down. It opens up if this coefficient right here is positive. Okay, so if p is greater than 0, if this part right here is positive, it goes up. If this part right here is negative, then the parabola is going to go down. For this one, if the 4p value is positive, it's going to open to the right. If this value right here is negative, then the parabola is going to open to the left. Okay, so just like ellipses, we're going to find that to get the information for a parabola, to be able to take information, write an equation for a parabola, that for most of the time it's going to be easiest for us to draw a picture of the information, because then we can use our common sense to relate it to these diagrams and find the rest of the information we'll need. All right, so now that we know all of that stuff, we're going to go ahead and actually do some problems. So here's our first example. We're going to graph y minus 2 equals x plus 1 squared. So if you compare this to your diagram, it's almost written in the order of this one, but the x term is the one that's squared, so it's actually this one right here, and it's just kind of written backwards. So what I would do first is I would probably just switch the order. So I would say, okay, this is x plus 1 squared equals 1 times y minus 2. I'm writing it this way so I get as close to it looking like this as I can. So that means that the vertex of the graph is going to be -1, +2. Because this value right here is positive, I know that it opens up. Right? If I look at the rest of the information to solve for p so that I can draw the focus and draw the directrix, then I'm going to say that 4p equals 1, because this is the spot where the 4p is. So I can go ahead and divide by 4, and I get p equals 1/4. So I'm going to go ahead and start drawing this picture. So I'm going to go left 1, up 2. I know that this graph is going to go up. And from this point, my directrix is going to be, I'm going to draw just a little sketch like this. If the graph goes up, that means that the focus is going to be 1/4 above the vertex, and the directrix is going to be 1/4 below the vertex. All right, and then from here, I would go to the right 1/4 and then another 1/4. I would go to the left 1/4 and then another 1/4. And so these, the endpoints of the lattice rectum, are half this way and half that way. And then I can draw my parabola. So you can see that if this is half and this is half, then that entire length is 1, which is exactly what we expected. Okay, so I'm going to go ahead and write down the focus. The focus from the vertex, the x-coordinate stayed the same. The y-coordinate went up by 1/4. For the directrix, I have a horizontal line, so that's going to be y equals. It went down 1/4 from 2, and so that would be 1 3/4. And you can write those as mixed numbers. If you wanted to write them as improper fractions, you could. So this could be written as 7/4. That could be written as 9/4. All right, so next we'll go ahead and write down what the endpoints of the lattice rectum are. We had gone up 1/4 and we had gone left 1/2. So the up 1/4 part, and then if we were at -1 and we went left 1/2, that would be -1.5. If we went to the right 1/2, that would just be -1/2. And you will find yourself getting a little bit better at fractions just because these p values often are fairly small. And then here, the length of the lattice rectum will just be 1. Okay, let's go ahead and try another one. So for this one, we're going to graph 4 times x plus 6 equals y minus 2 squared. So again, I'm going to go ahead and switch the order to make it match the way that it looks in my packet. So here, since this one is a y squared equation, that means that for my diagrams, I'm looking at this one right here. So again, HK, the H value from the vertex always comes from the X. So you're not necessarily going from left to write your HK. You're always going to start with the X and then write the Y. So for this one, the vertex would be -6, +2. All right, and then we'll go ahead and do the work to find the value for P. So for P equals 4. So P equals 1. So that means that the vertex is a length of 1 away from the focus and 1 away from the directrix. If we look at this equation, since it's y squared, it's going to open to the right or to the left. Since this 4 value is positive, that means it's going to open to the right. Okay, so let's go ahead and draw a picture of this. We have to be able to go up 2 and left 6. Should have made this a little bit bigger. Well, okay, so left 6, up 2. So to be able to draw the focus and draw, oh, that's not going to work. Well, hopefully you did a better job drawing than I did. My line's just going to go over some of my writing. Okay, left 6, up 2. My focus is going to be inside the parabola. My directrix is going to be on the other side of the parabola. So there's the directrix, there's the focus. From the focus, I have to go a length of 2p to be able to draw the rest of the parabola. So I'm going to go up and down 2. So 1, 2, 1, 2. And there's my parabola. My drawing is way too big. All right. So if you can see, this right here has a length of 2, which means that the whole thing is a length of 4, which is what we expected. So let's go ahead and write down all the rest of the information. So we have the focus. From the vertex, it went to the right 1, and so that means it's at -5, 2. The directrix is a vertical line this time, so it's going to be an x equals equation. And it's going to be x equals, this went to the left one, so x equals -7. And then we have the endpoints of the lattice rectum. So they went up 2 and down 2 from the focus. So we're going to keep that x coordinate of the focus. And then if we went up 2, that's 4. If we went down 2, that's 0. And then the length of the lattice rectum is 2 + 2, which is 4. Okay. Let's go ahead and do another type of example. So for this one, we are going to find the equation of a parabola. With a vertex of 2, 4. And a focus of 2, 5. So what I'm going to go ahead and do always is just draw a little sketch. And my sketch is just to help me figure out the orientation of the parabola and figure out what my different values are, so your sketch at this point doesn't have to be as accurate as these other two were. So I'm going to think of my vertex being right 2 up 4, my focus being right 2 up 5. And so that means that my parabola is definitely going up because the focus is always on the inside of the parabola. So since the parabola is going up, I know that that means I'm working with the equation that is x minus h squared equals something times y minus k. Because it goes up, I know that this value right here is going to be positive because it goes up. So the vertex is 2, 4, so that should be minus 2 and minus 4 to make a positive 2 and a positive 4. I know that this distance right here to go from 4 to 5 is a distance of 1. And so that part right there tells me that p equals 1. So since this part right here is supposed to be 4p, then 4 times 1 is just 4. All right. And I'm done. That was all I had to do. All right, here is our next example. We are going to find the equation of a parabola with the focus 2, 0 and the directrix x equals -4. All right, so I'm going to go ahead and draw a sketch. So 2, 0 would be like right here, -4 would be over here. So this means if the focus is right here and the directrix is right here, then that means that my parabola has to open to the right. So what I'm going to do is say this is y minus k squared equals something times x minus h. Because this is right here on the x-axis, I know that the value with the y is going to be a 0, so I can, if I kind of guesstimate, I think the vertex is going to be about right there, right? So I know that the y-coordinate is going to be a 0, so you can say plus 0 or minus 0, it doesn't really matter at that point. So now what I need to do is I have to find the middle of these two numbers. So this is positive 2, this is -4. I just need to find the middle of those numbers. So to find the middle, you just have to add them together and divide by 2. It's the same idea as what we did before where we found like the midpoint. So I'm going to say -4 plus 2 divided by 2. So -4 plus 2 is -2. -2 divided by 2 is -1. Does it make sense for that x-coordinate to be -1? Absolutely. So this distance right here is 3, and this distance right here is 3. So I'm going to put plus 1. So we have our vertex is at the point -1, 0. Right. Now, since we know that these have to be equally distant, right? They're each 3, and we know that that distance is your p-value. And so that means this number right here would be 4 times 3, which is 12. And there's our equation. So if we want to write it in most simple terms, we would write it like this. All right, and then one last example. We want to do one where we are completing the square. So we're going to say, given x squared plus 6x minus 4y plus 1 equals 0, and we're going to put it into the conic form for a parabola. The standard conic form. So when I do problems like this, what I usually do is I get my packet out, and I just know that these two are kind of my goal for what this problem should look like. And actually, this is a problem with an x squared, so that means my goal is for it to look like this. So that's what I'm going to keep in mind as I do the problem. So that means I'm going to keep the x squared and the 6x on the left side. but I'm going to move the 4y and the 1 over to the right side because everything else should show up over here. So positive 4y, negative 1. All right, then I go about my process for completing the square. So 6 divided by 2 is 3. 3 squared is 9, so I need to add a 9 right here. And if I add a 9 to the left side of the equation, that means I need to add a 9 to the right side of the equation. So now I have something squared equals the stuff over here. So I have x plus 3 squared equals 4y plus 8. So you can see it's pretty close to what it's supposed to look like, but it's not quite there yet. I need to have the y written in the parentheses by itself. So whatever the coefficient is, I need to take that out. And so that means I'm going to have x plus 3 squared equals 4 times y plus 2. So now I have it written exactly the way it is here. I know that I have a parabola that opens up. I know it opens up because it's a 4. It has a vertex of -3, -2. It has a p-value of 1. And so from here I could do all the graphing that I needed to do, and I could find all the extra information I need to find.